everyone, it's Judy Warner. Welcome back to this week's Ecosystem Podcast. Today, I'm joined by Simon Rance, who's the Director of Product Management at Keysight. Simon came along with the acquisition, you may remember, about a year and a half ago of Cliosoft, and they have some really innovative products when it comes to data management and PLM, but of the silicon design. I think you're really going to enjoy this podcast. I put some great notes for you below, so make sure you go check those out. Now let's jump into our conversation with Simon Rance. Hi, Simon. Thanks so much for joining us today on the podcast. I look forward to talking to you about all the exciting work you're doing.
Hi, Judy. How are you doing?
Good. Well, for our audience, you have an interesting background in the sort of EDA space, and tell us a little bit about your background and sort of your technical interests and what you do for Keysight.
Sure. So I have quite a broad background. I've been in EDA for about 25 years or so, through all aspects of it, from marketing, sales, product management, application engineering. So kind of a good breadth of that across digital, analog, mixed signal, and even some RF microwave as well. Currently, my role at Keysight is I'm Director of Product Management for what we call our Process and Data Management portfolio or business unit. And we have two products that I currently manage. One is our Design Data Management Solution, SOS, and our Engineering Lifecycle Management Solution, Hub. And these two tools and myself joined Keysight as part of the acquisition of Cliosoft about a year and a half ago.
Okay. So tell us a little bit about both those tools, and then let's talk about from an EDA standpoint. I have some follow-on questions. So tell us a little bit about those two products, and then I've got a follow-up question for you.
Yeah, sure. So we have two products, as I mentioned. Cliosoft, before Keysight acquired the company, had been around for about 26 years. And so we have quite mature products. Our most mature product, which is what Cliosoft was originally founded upon, is the Design Data Management product that is geared towards hardware silicon and semiconductor design. The other product, the Engineering Lifecycle Management Hub product, helps with IP management, traceability, essentially addressing kind of a PLM or PLM light type solution that is dedicated for an engineering lifecycle for semiconductors and silicon and chip designs.
Okay, so since I sort of come from the PCB board level side of the fence, how does the data management, how is that handled differently between semiconductor level versus, say, software or like PCB data management?
Yeah, so one of the main differences is that for hardware engineers, there's a lot of data compared to, let's say, software design. So there's a lot of data management solutions out there. Primarily, they are geared towards and focused on software development teams. Whereas we saw a niche or a capability that was missing in the hardware design world about 20 plus years ago, where managing large design files like schematics, layouts, especially for analog design, for example, a mixed signal. And then how do you manage that across multi-site teams, either within the same region, country, or even globally as well? So these were some of the unique things that started to make us realize that we needed something more geared towards hardware development, specifically for chip design, that the software data management solutions were providing.
So tell us a little bit about, so you found this niche, right? And so I can imagine semiconductor designs are extremely dense. And so does this data then, do those products, since it's an EDA, data management PLM tool, do those live in the cloud, or are they on premise? Are there security concerns there?
That's a good question. We have customers that use our solution on premises, and that's I would say the primary or the most common scenario. We have some that do use it in the cloud as well, but Typically with the cloud, it's a hybrid model, where parts or most of the data is on premises. And then when certain things need to happen, let's say if it's you're running some verification that you need to really crunch down that time to verify, a lot of the times that data then gets moved to the cloud to get that processing power and the compute power necessary. And that's where we have those capabilities, and we have customers that use our solution for that hybrid on-premises cloud type scenarios.
Okay, makes sense. So one thing that I've been observing while dealing with various people across Keysight, but across the industry, that I'm really encouraged by is the ability that people are starting to collaborate, right, more digitally, and giving the engineers a better experience to sort of stay in a limited number of EDA tools, even though they might be different tools. Do you offer something like that where it can work alongside different EDA tools?
Yes, that's one of the key differences between data management for software versus hardware design. With EDA design flows, because of the complexity of those flows, the methodology, and the tools that are used, our customers are having to use, very complex tools. It builds a lot of data very quickly. So those file sizes and the sheer amount of data grows very quickly. And one of the big things is that design engineers and hardware design engineering teams, they want to minimize the chance of error, one of the things, as well as security concerns, right? So the more the data gets moved in and out of multiple tools, the more room for error. Just a natural thing that will happen, right, as you're moving and importing and exporting data in and out. But it can also then, what happens if you don't import or export all of the data right into the next tool? You can have other processes and flows downstream that you don't realize became a catalyst from that point of view, right? And this 1 to 2 weeks later, they realize, oh, we took the data out of this one tool, put it into this other tool, but didn't have all of the information it needed. And so verification run was incomplete, or our test results are incomplete. So what our customers have been asking and looking for quite some time now is having the ability to move the data less between tools and flows and have them native side of their EDA tools.
Do you think that's a market driver for what I'm seeing?
Yes, definitely.
Okay.
We have our solution as a standalone, but most of our customers use our data management solution natively inside their EDA tools so that they don't even have to leave them. If they use more than one tool, they can use the data management in both of those tools, not have to move the data between them.
So how do your tools connect with other EDA tools? Like, what is that connector, or what is that experience like for engineers that may be in our audience? What is that like?
So we have tight integration with all the major EDA tool partners. Keysight, one of them is our Keysight ADS for RF and microwave. That user experience is, if you're inside of Keysight ADS, you have just there in the native mail menu system, you select our data management solution. You can check in, check out files, you can tag, you can do branching, you can do everything you can do in our standalone data management solution, but you can do it natively within that tool. And if you have another tool in the flow that may be from one of the other big vendors like Cadence or Synopsys or Siemens EDA, their tools as well. We have plugins and integrations natively inside of those, so that our design engineers that are using both solutions, ours and those EDA tools, can securely manage data.
So if they're in, say, Cadence or inside Mentor Siemens EDA, then they can stay in their design tools and still access that data.
Exactly. So if it's analog design, they may be using Cadence Virtuoso. They can just access data management from their menu system.
I really love this trend. I think it's making things easier, I'm sure. So when we're talking about this, you're definitely talking about enterprise teams, I take it.
Yes. Enterprise teams, a lot of collaboration, a lot of traceability that's needed.
So let's talk a little bit about that. So traceability, there's obviously some applications like automotive or military that have rough demands on traceability and security in that. So what kind of applications do you see? And what is sort of ensuring that you get that traceability functional and working in there so that, we don't crash our cars or
Yeah,
jets?
exactly. So that's where our other solution, our other product, the engineering lifecycle management solution comes into play. And that is
Okay.
really when you look at large organizations or even medium-sized organizations, different teams will use different data management solutions. And it may not be the same solution because in the past or historically, they worked more in silos, right? So a verification team doesn't always necessarily work directly with the hardware team or the software team or the test and validation type teams. So they'll pick their solutions, but you need to basically bring all of those data management systems together under one single source of truth. And that's where our engineering lifecycle management solution hub basically integrates natively into not only our data management solution, but all of the other major ones out there that are used for hardware, even software design as well, so that you get this holistic picture of the entire engineering lifecycle, all the data, no matter where it actually may live. It could live on premises, it could be in the cloud. It doesn't really matter to our solution because we can manage both simultaneously. And so by having that single source of truth, then you can have true end-to-end traceability. That's really the critical requirement for automotive applications that require functional safety and ISO
Right.
262 compliancy. Same
Yeah.
with the military aerospace applications.
What are the years of traceability requirements these days? Like years wise, how long do you have to hang on to that?
That's a really good question because I would say for a typical design cycle, a lot of the times it's just erased within weeks to
Yeah.
months after the design cycle.
Yeah.
But for industries like automotive or military aerospace, typically the requirement is a minimum of 5 years to 10 plus.
Yeah.
Really the life cycle of that device or system being in the marketplace for any type of audit trail and traceability. But we're seeing some of those requirements that were exclusive more so to those industries are now coming into play. Even the semiconductor, consumer, IoT, server markets as well. Because if something does go wrong, once that device or system goes into the field, if you don't have the data to trace it all back,
Right.
you're pretty stuck. So
Yeah.
really for most semiconductor and hardware system design companies, it's up to them on how long they typically save the data for. But more are doing it, just like the automotives and military aerospace industries, and more starting to look into what types of data do we save and for how long for AI, ML type applications for future designs. So that's kind of a new area of that as well.
Back when I was in the PCB fabrication, working with large OEMs and mil aero, of course ITAR was mandatory, and before digital, like we had like bonded rooms, right, where we could keep data and all of that. How do you manage, like, is there a guideline for, say, ITAR, that as you store these massive amounts of data and that you have all this available and maybe for years, like how do you manage things like ITAR?
Through a lot of different mechanisms, from access controls, from tagging to branching to just preserving the information as well as securing the information as well. So that's a big aspect of it, is the security aspect of IP, who gets access and see what, and that's becoming a bigger thing. The more collaboration there is, the more
Right.
chances of security breach. So it's that fine tuning of how do we enable more collaboration, but also increase the security of the IP or the data. But ITAR in itself has kind of its strict kind of guidelines that you have to follow on processes. But most companies even impose even more on top of that because, just indemnification, legal.
Right. Okay. And it is interesting, a global economy, who can look at what, right?
Yeah.
It's a challenging thing to manage. We didn't talk about this ahead, so I'm going to sort of put you on the spot on this one a little bit. Like, can you share with our audience something like a really interesting case study, like this is how their design flow went before, and then they integrated, data management with this PLM, and the rainbows came out and the unicorns, or, whatever, that it was one way and it's another.
Yes, I can. Some of the really good ones we have are in kind of more of the automotive, military, aerospace, so I'm not able to share exactly those particular case studies and success stories. But we have had one recently, which you'll be able to find information about that on Keysight.com, and that's with one of our great customers called Allegro. And Allegro is used both our data management solution for hardware designs, but then also our engineering lifecycle management hub. And from managing that entire life cycle, everything from the specifications, the requirements, the architectural spec, all the way through to tape out, all of that is managed from end to end, not just the data, but even the engineering know-how. So as engineers start to integrate IPs together, maybe an IP won't connect one-to-one to another IP. What type of glue logic do they have to create to get that to stitch together? That is actually being captured as well. So that intelligence, that know-how is being added to that IP, to the system, so that on a future project, engineers can say, oh, this is how these two IPs were actually successfully integrated together on a previous project. We can just leverage this glue logic that's also been checked into the life cycle of that project. So you have all of those kind of going through, documentation being managed, reports auto-generated, so that you have that bill of materials and hierarchical traceability, so you know what's being used by whom and where in the company, as well as any other type of restrictions that might be there security-wise, for example. But for Allegro, their case study was a 50% improvement overall in that entire engineering life cycle in terms of productivity, time, and market savings.
That's huge. That's really huge. Sure, it took a minute to get it set up, but like how much time that will save over, it'll probably be millions or billions of dollars. That's crazy.
The more that gets preserved, kept, managed data-wise, the more the savings are, the productivity boost, the time to market savings. And that does vary from customer to customer. The more time that customer has to invest in putting more knowledge, more data into the system as they go along through the engineering life cycle, the more they can get out of it in terms of reuse in the future.
Yeah, totally makes sense. Sounds way more efficient and wise.
Yes.
Especially with the load engineers have right now and the complexity. So, the way that I really was introduced to you, Simon, was I know not too long ago, you did a talk with the Keysight's EDA World Connect Tour. Before I let you go, can you tell us a little bit about that? And then I want to get that link from you. So if people are interested in learning about sort of innovative ways to handle their semiconductor data management, PLM, they could go check out that talk.
Yeah. So what I did was I gave a bit of a high-level executive summary of what exactly the type of problems that we're addressing with both the design data management solution as well as Hub for the engineering lifecycle management, and how the two together can give you the type of benefits that, say, Allegro was able to accomplish. I kind of take it through one by one how that's done as a process at a high level, just to give a bit of insight in how that's done. But then I also touch on a lot of other type of common day-to-day engineering lifecycle problems that people will see or go through, and how we address those as well. And so I can't go through every problem that our solution addresses, but it's interesting how many engineers just do the same thing over and over again, not realizing that they can save a lot of productivity if they just solve it a little bit differently this way and with our solution.
Yep, that's the challenge, isn't it? To stop doing the things the way you've always been doing them, to maybe pick up all that productivity and get out of your comfort zone. Well, Simon, thank you so much for that. And I'll make sure that I share that in the show notes and send folks that way, because I know I would love to. Podcasts don't give you, nobody would listen to me. Or maybe you either, Simon, talking about, but I want to give folks a chance to go do that if that's an area they're interested in. So thank you again for coming on the podcast and telling us a little bit about your talk, and good luck with both your projects, and hopefully in a little while you'll come back and update us as you get down the road a little further.
Yes, definitely. I appreciate it. Thanks so much, Judy, for your time. It's great to be on your podcast.
Yeah, thank you. For our audience, thanks so much for joining us today. I hope you enjoyed this sort of executive view of what's going on in the industry in regards to silicon data management and PLM. I'll put some great links for you in the show notes. Until then, we'll see you next week. Always remember to stay connected to the ecosystem.